Okay, today is the review day for the test. The test is going to be tomorrow. Then, what do we do on Friday, the last day before spring break? You can use that day to study and maybe do this tide lab in class. Maybe get that over with before break. I could even just assign it as due at the end of that day. But if you want to take the time to do a really good job and look up a really cool place you're going to get your tides, maybe you'll want to take some more time to get it done. So this is not going to be due until the Friday after break. Okay, so you'll have plenty of time. But maybe you'll get it done a lot quicker than that. So here's a typical tide question, and I'm going to give you a second to write an equation for this tide situation. 3 a.m. low tide, 10 foot, noon, 16-foot high tide. So let's call on somebody here. Dice of Destiny. This is row 4, person 2. That's you. You're person 2. You know person 2. Okay, so what do you think? How do I start this thing? It's kind of walk me through it. I don't want just the answer. Tell me how you did this thing. And they are at what? 13. And then what does that tell you? It tells you two things about your equation. There's a name for that. It's a shift of 13. And the amplitude is 3. Very good. Okay, so that little dotted line tells you the beginning and the end. The middle stuff had an equation. Can you tell me the equation you used to find that middle stuff? Both the B term here and then the C term, that would be the shift in there. One thing at a time. What's the equation involved? B, because this is the B term, okay? And then, did I tell you B? No, but you can figure it out from the period. So what was the period of this guy? It went from 3 to 12, which goes this way time-wise. And how many hours was that from 3 to 12? 9. So then why didn't you just use 9 as the period? It's not a full period. It only goes up. It's only at the up cycle. Yes? Oh my God. It's okay. It's all right. That would be to 10, but we're going to 12. So, all right. So 9 hours, and then you double it makes 18, and then you have 18 for the period, and then you flip-flop the B, and you get B equals 2 pi over 18, or if you're going to reduce it, which would be good to make sure you don't lose points for little putsy stuff, it has pi over 9. Pi over 9 goes right here. And last but not least, the shift. The shift is from noon, from midnight. How far to the first, not low tide. So you should not have gone to here, because that would not, if you shifted over that far, if you shifted it that far, you would actually not have sine or cosine as your main function. You got to find the first high tide. Think of it this way. Here's my graph. Here's what cosine is supposed to look like. And it's been shifted. We're looking for, it's normally peaking right here, highest spot of cosine. So again, how far over is the high tide shifted to? And the high tide was at noon. So, what is it? Minus 12. Raise your hand if you had that one right. Awesome. Okay, so all you have to do for your tide lab, first of all, there's a folder in Schoology called Labs. Find it. And I want to find it myself here. Hold on a second. And in that folder called Labs, you will find one called Tide Lab. And in it, I hope it's clickable for you so you don't have to retype in all this .biol, .sc, .edu, etc. But I'm going to click on that. It should bring me to the site. Pause while that loads up. Okay, and that brings us to this website. And this is kind of cool. It's got a map here that can show you where all of its sites are that you can use to like get tides. And maybe you are intrigued at the idea of finding out what the tides are like in Hawaii. Then you can look them up. And let's just find a spot to look up. I'm going to pause while we do. Okay, so I just found I clicked on one of those little red dots and I picked this site. And by the way, because I picked this site, nobody else can use this site. There's a bajillion of them that you can pick. So I just don't want you to use my exact problem and be done with your lab by the time I'm done with explaining it. Okay? So I really do want you to pick something that means something to you. Like, I went on a trip there. Or it's a place I want to go. Or I've always been obsessed with the East Coast. Or whatever. And I'd like you to put that in your lab. Why did you pick the spot you picked? Okay? It's not going to be that hard. If you have to lie about it and make up some reason that you were abducted by aliens and brought to Poughkeepsie, feel free. All right. But I really would love for you to make this interesting to you. All right, so here we have sunrise, moonrise. Those are not things that I need you to record. But it looks like my first high tide here happened at 5:28 HST. It's probably Hawaii Standard Time, I'm just guessing. Or anyway, I know PST would be Pacific Standard Time, but I'm not sure exactly what HST is. But we're going to say that that is our time. Don't worry too much. We're not going to like make these all go back to Greenwich Mean Time or something. We could make it more complicated by that. Is it Hawaiian? Okay. Then there's our time, and we had a high tide of that many feet. Now, one thing that's going to mess with your life a little bit here is we always did numbers that were positive, you know, like 16 feet and then 20 feet. Okay, it's easy to find the number between them. But then here, our low tide was at this time. Now, what happens when we go, and thankfully they use military time, so you don't have to worry about AM and PM, because if it goes to 1852, you know it must be in the later part of the day, right? Okay, hold on a second. So how are you going to deal with a 0.96 compared to a 0.12? Well, just for perspective, here is like what 0 is. 0 is like sea level, okay? So if they said it's 0.96, the real world's icky. I would have said 1 foot, okay? But they're being really accurate, so it's just above, for its high tide, it's just above this at 1 foot. I'm rounding now. And just a tiny bit below it, and it cycles back and forth like that. Okay? So can you still find the midline by averaging the two numbers? Sure you can. It's just one's positive, one's negative. It's okay. It still can be averaged. Like for instance, let's say I had it go up to 1, like normal sine and cosine do, and down to -1, then what's the average of that? 0. And that's okay. The midline is right at 0 for sine and cosine, right? And you still, the midline is this line that runs down the middle, and it's still going back and forth between 1 and -1. So don't let it freak you out that there's a negative number in there. All right, next thing. There's 2 high tides and 2 low tides. I want you to average 2 highs and 2 lows, because I don't know if you've noticed this, but the real world again is icky. It's not as simple as it always goes to 1 foot and then the next high tide's always at 1 foot. Nope. This high tide was a higher high tide. So you got 2 high tides, you got 2 low tides. And because they're slightly different than each other, you need to average them and then do your problem with that data. The average high tide, the average low tide. And then, but wait, what about the times, Mr. Server? Then, how long was it between these tides, and you average that? There was about 12 hours between this one and about 11.5 hours between this one. Well, then average that, and you'll know. You can find the period pretty easy if you just go from high tide to high tide, or low tide to low tide. All right. So basically, do some averaging of your data, because if you have 2 high tides and 2 low tides, and they're slightly different, you can't use all of that data. So average your high tides, average your low tides, figure out the average amount of time between the tides, and then you'll be able to find your period. once you know the period and the center line, the average of the high and the low tide, it's easy to finish this problem. Okay? So what's special about this is we're just getting it to be dialed into the real world, and you will have an equation for a specific place that you are kind of interested in. Okay? So make sure you include screenshots, because I'm going to ask kids as you're grading this, to get a good score on this, you're going to have to include, like, why was this important to you? Where was it? Maybe you should take a screenshot of, like, the map and say, this is kind of where it is, and this is why I'm interested in it. Include that in your lab. It's not too tough. All right, you could easily be done with this. Honestly, if I said it was due at the end of the hour, you could be done with this, you know, with only the time you have left in this class. But we need to spend this time reviewing for your test. So, all right, so there's a little intro into the tides lab. It is something that's included on your test. So, hey, we got one concept studied. All right, let's study a little bit more stuff. So, one thing that we haven't talked about in a while, and yet comes back, is this. Do you remember circle trig? Do you remember me saying that this whole semester that we would weave old stuff in with the new stuff? Well, that means that on any test, you could be given any of the old stuff from this semester at any time. So I want to remind you how to do circle trig. Do you remember that there was a triangle involved with this? In fact, there's two. There's almost always two answers. And you can narrow it down to one answer if I said, oh, by the way, in this same quadrant, tangent of theta was negative. You know, so that since all students take calc, if tangent was negative, then it couldn't be here, because that's where tangent's positive, and it couldn't be here. And where would sine be negative? Well, sine's positive here, so it can't be here. Oh, it must be here then. And I'll finish this one, and we'll have you do one like it. So what angle is this? Well, I got to do my sides. I got sine, so it's opposite and hypotenuse. And so I was given an opposite side of negative root 3 and a hypotenuse side of 2. It really confuses people if that negative moves to the other spot. I hope you get that you can't ever have this side be negative. So then the negative here could be here or here, and it doesn't matter. You put it where the appropriate spot is on the drawing. And then last but not least, the third side is, I know this one, 1, 2, root 3. So then what's across from the 1 is a 30. And so this must be 60, but we do everything in radians. So what's 60 actually in radians? Pi over 3. So this spot is not 60. And you never give negative angles, because they're going to say, I want the angles to be between 0 and 2 pi. So that means you can't give a negative 60 for an answer. You can actually, in our next unit, it's the only time you use negative answers, and that's in inverse trig. You'll learn more about that then. But instead of saying negative 60, you'll have to give a positive answer. So that's positive 360, except not quite, not that far. So that's positive 300 would be your final answer for this one. But wait, you said I should use radians, Mr. Server. Okay, then 300 is a whole bunch of 60s. How many 60s was it? 5 60s? No. 6 60s. Yeah, actually it would be 5 60s. So 5 and 60s are pi over 3s, so 5 pi over 3. Another way to think of it is this. 1 pi over 3, 2 pi over 3, 3 pi over 3, because that's where pi is. 4 pi over 3, 5 pi over 3. That must be 5 pi over 3. There's your answer for that one. What if I hadn't said this part about, hey, by the way, tangent is negative? Well, then, if you didn't have that restriction, you could have made one here, too. And there would have been 2 answers. The one I'm about to ask you to do, there'll be 2 answers. If cosine of some angle is negative 1/2, would you please figure out what angle that must be? Use circle trig to do it. There is a way to do this with graphing trig, but I think it'd be better to do it with circle trig. So I'll show you how you could have done it with graphing trig too, but try it with circle trig. Okay, first off, cosine was negative. That ruled out 2 of the spots. Oh, students, take calc. Cosine was negative, so we couldn't be here or here, because those are places that cosine is positive. How many of you were in the right 2 quadrants, quadrant 2 and quadrant 3? Raise your hand if you had that part right. Good. Okay. Next, if I'm going to make a triangle here, I should be a little more careful here. Goes up to there and drops straight down. And then cosine, adjacent over hypotenuse. Adjacent side, -1. Hypotenuse side, 2. And then 1, 2, and this must be root 3 over here. And the one across from the 1 is a 30. That's the way I always do it anyway. And that makes this a 60. So is 60 degrees the right answer? No. If I put it in radians, how about pi over 3? No. Because pi over 3 is over here. Where are we? 2 pi over 3. So 2 pi over 3 was one of your answers. Okay? And the other answer would have been down here. And I do not need you to recreate the whole thing, because if you know this is a 60, then that's a 60. Also known as a pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 is the other one. Raise your hand if you had that one right. Good, you haven't forgotten circle trig. Cool. All right. Now let me show you how this could have been done with graphing trig, but go ahead with your question.
I'm curious, why would you say, like, for that first one, say, like, 2 pi over 3 or, like, 120?
Yes, 2 pi over 3 or 120. Go ahead.
For the next one, why would you say, like, 180?
Okay. The next one, if it 180, remember, is right here. Okay, so 1 pi over 3, 2 pi over 3, 3 pi over 3 hits 180. Okay, and then one more to get down to where we are. We're at this spot at the final. Okay? We had 2 triangles, one here and one here. Glad you asked, though. All right, so what if we had to do this with graphing? You could have. It's kind of cool. Do you get I could have graphed cosine? Do you guys please draw the parent cosine? Just draw parent cosine. I think this will make sense to you. We'll see. And maybe somebody will choose to do it with graph. As long as you show me your work, I'll be fine with either one. Parent cosine, including all the labeling. I already see one of my really smart students graphing sine. Don't forget cosine. Starts at 1, makes a valley. Cosine. We're graphing cosine right now. Okay, when I make it in 4 parts like that, it usually comes out the best. So 2 pi, pi over 2, 3 pi over 2. All right. Now, I labeled this with your classic 4 major parts, okay? Now, I want you to think about what this question means in terms of where is cosine negative a half? Well, this is where cosine's -1. See what I'm saying? So where is cosine negative a half? Well, if this is -1, negative a half would be right about here. Do you see it hits twice? Once here and once there. So where is cosine negative a half? Well, I can draw my line through it and say here and here. But it's here and here. How am I supposed to know where those spots are? Do you get that they are dividing up 2 pi here into like 1/3 size chunks? I'm going to say that again. We didn't hit right at pi over 2, did we? What's something that's just a little more than pi over 2? 2 pi over 3. That would have been right here. What's something that's a little less than 3 pi over 2? just a little less than 3 pi over 2. I think you can guess from the context. Must be 4 pi over 3. All right. Now, that one didn't work really nice because it didn't happen to hit on our graph really nicely. On our parent graph, what would have been a much easier question to ask about cosine? Instead of asking, when is cosine negative a half, what could we have asked that would have been like, oh, easy? Pay attention now. Okay, so what could I have asked here? Cosine is equal to what? That would have been easy to answer from this graph. Like what? Cosine of a half is negative 1. Good. Did you get there would have only been one spot? And what would the answer have been? Pi. What if I'd have said, where is cosine equal to positive 1? Do you see I could have got that answer here and here, which would be 0 and or 2 pi? I'm trying to show you how this connects to circle trig. All right, how about 0? Do you get I could find where cosine is 0 pretty easily too? Yes? Hold on. So where is cosine 0? It's when it hits here and here, which would have been answers of pi over 2 and 3 pi over 2. So it would have worked really well for, what were all those spots? I'll remind you, they were things like pi, pi over 2, 3 pi over 2, pi, 3 pi over 2, pi over 2. Those are all the quadrantals, they're called. Those would have been easy questions to answer with the graph. Okay, now I can answer your question.
Was there like an infinite number of answers?
Yeah, there is an infinite number of answers. That's, in fact, there always has been. Even on circle trig there was. Because if you want to say that the answer is 0 degrees, couldn't you also say that it's 360? Because they're in the same spot. Couldn't you also say it's 720? See what I mean? So there's always been an infinite number of answers. We've always said only give the answers between 0 and 2 pi. Because, I'm glad you're seeing that though, there's an unlimited number of answers. So like, when is cosine a half? Positive a half. Well, I go to 1/2 right here, and I just go, whoosh, and it would cut through cosine, well, 2 times that we can see, plus a bajillion more over here and here, etc., etc. So yeah, there's a ton of answers. That's why we limit you to only giving the answers that are between 0 and 2 pi. Okay, I'm fine with you doing it with circle trig. But it's just also good to be able to whip out a graph and say, well, I can tell that that answer must be this from the graph. I'm going to ask you to do one more. Make me the graph of secant. Just to remind you that those are going to be on the test too. Graph secant. Parent graph of secant. Stay with me. Stay with me. Focus. Parent graph of secant. Do it on your scratch paper there. It rides on the back of the sister function. Sister function sine. Hope you started by graphing sine. Oh, wait a minute. I said secant, didn't I? Not cosecant. Sorry. Secant rides on the back of the sister, which is cosine. My bad. I said secant. I should have written it. Secant rides in the back of cosine. So here's a question you could answer from the graph. If you've labeled these things right. Oops. Secant of theta is equal to -1 someplace, isn't it? What angle is that? Well, first of all, I haven't even drawn secant, so I better draw secant. Secant is the one where it has asymptotes, where cosine, its sister function, hit. And then it has loops here. And I'll take out the original now. There is secant. Where is secant -1? Look at the spot on the board. Burn into it with your laser eyeballs. Hopefully you're hitting right there, right? Okay, so then what's that spot? If I had labeled them all, it would have been easier. 2 pi, pi. Apparently it said pi. So theta must be pi. Raise your hand if you would have got that right. Okay, good. What if I had said, now that we're looking at the secant graph, tell me a time when secant is equal to 1. Can you see that it actually was here or here? And the answers would have been what or what? 0 for that one, or what's the angle here? 2 pi. Okay. That's the last thing you need to know. Now, we've done a ton of them where you stretch them and stuff. What if I give you the equation and you have to not graph it, but tell me stuff like, here's a, and actually, instead of a picture, what if I said, what's the period of this function? Don't say it. Figure it out. What's the period of that one? I'll pause for a second. Let me give that a try. Okay, did you pull up out of your memory banks that the period was 2 pi over b? And then I don't know the period, but I know b. B's 2. And therefore, a period would be 2 pi over 2. Cancel it out. It's pi. Raise your hand if you had that one right. Okay, awesome. What's the amplitude of this one? 3. All right, I have one last thing to show you, and it's very important. It is worth your time. Let's take a look at this one for a second. You had one of these on your homework last night. I hope you paid attention to it. I'm going to show you another one right here. So if I just have A, B, and C, hey, at least they aren't going to make me figure out a shift of D. They're saying it was not shifted by saying that. This doesn't start like any of your functions. It goes down right away. It starts kind of in the middle. What is that more like? Is it more like sine or cosine? Well, I hope you know it's more like sine, except it's been flipped. Do you get this has been flipped? Wouldn't sine normally have been like that? You know what I'm saying? Well, the fact that it has been flipped told you which of these numbers was negative, A, B, or C. Which one was negative to make a up-down flip? A would have had to have been -1. Okay? Okay, if it has to be positive, then the only other way it could happen, if they tell you that, like it did say, if this had to be positive, how could you get sine to be there? It could have been shifted. Here's where sine would normally have been. How far did it get shifted until it looked like that? Well, here's where sine would have been. That's normal sine. It apparently got shifted either that way or that way. And how could you shift it that far? You would say pi over 2. All right, that's all I got for you for today. Your homework, study. There's more review problems on the same review sheet, and there's a key for it. That's what I would do if I were you. Test is tomorrow, if that wasn't clear.